So now we're going to do some more complicated factoring binomials using difference of squares. And so like here the example is 25x squared minus 9y squared. They're saying here a is 5x, b is 3y, so we do 5x plus 3y times 5x minus 3y. And just to note that exponents divisible by 2 are perfect squares. So if I have x to the fourth, that's divisible by 2, so x squared and x squared. Two ways I can get that. If I have like x to the 12th, I can think of that as x to the 6th times x to the 6th, so my square root would be x to the 6th. All right, so let's look at some of these. So for number 11, well, first of all, I got a greatest common factor of a, so I'm going to factor that out. So that gives me 36x squared minus 1. And now I'm going to take a look at this. And looking at this 36, a would be 6x. My b here would be 1. Now remember, I'm going to go ahead and I'm going to write my a down. Very important to write that. And then I'm going to write my binomial twice, one with a plus and one with a minus. So I'm going to have my 6x plus 1 and 6x minus 1. And so that would be our answer. Let's take a look at the next one. Well, I notice here these have a common factor of 2, so let's factor out the 2. So that'd be 64y squared minus 121z squared. Square root of 64 is 8, so a would be 8y. Square root of 121 is 11, so b would be 11z. My 2, of course, comes down for the ride. So I have 2 parentheses 8y plus 11z. In fact, let me make that y a little bit better. It looks like a g there. There we go. And then times 8y minus 11z. All right, number 13. Ooh, that kind of looks weird. So number 13. Well, let's think of it this way. Square root of 1 is 1. Square root of 4 is 2. So a is going to be 1/2 y. Square root of 9 is 3. Square root of 25 is 5. So I'm going to use 1/2 y for a and 3/5 for b. So we'll get 1/2 y plus 3/5 for our first binomial, and then 1/2 y minus 3/5 for our second one. All right, let's take a look at this next one. Now remember, if the thing is divisible by 2, the exponent is divisible by 2, then it's a perfect square. So in fact, my a here is going to be 7z. 8 divided by 2 is 4. I actually divided by 2. And then our b here, square root of 225 is 15. X. So now we just go and plug into our formula. First term is 7z to the fourth. Second term is 15x. So we get 7z to the fourth plus 15x times 7z to the fourth minus 15x. So that's our answer there, and I forgot to circle the answer over here. All right, let's try this next one. So again, even power, so it's a perfect square. So I'm going to divide by 2. When I take the square root, that gives me n squared n squared. My b here is 4. So I'm going to go ahead and plug this into my formula. N squared plus 4 times m squared n squared minus 4. Now if I type that into ALEKS and click submit, ALEKS is going to say it's wrong. And you might be wondering, why is it wrong? Well, look carefully at that. Notice that m squared n squared minus 4, that in itself is a difference of squares. I can break that down. Now I cannot break down this one because that's a sum of squares. So that stays put. But I can repeat this process again. Because this now, my a here, let me do it in a different color, would be mn. And my b here would be 2. So this piece here just comes down because it's a sum of squares. We can't break that down. But this I can break down further. So think of this like as an Energizer Bunny problem keeps going. And that's another thing that you'll need to start getting the practice of, is just kind of verifying that everything is completely factored when you break these down. So we're able to go a step further and break this down. So that's what we need to enter into ALEKS to make ALEKS happy. Let's try this next one. 32 and 162, well, they're even, so we can factor out a 2. So that gives us 16x to the fourth minus 81. Those are both perfect squares, so my a here would be 4x squared. B would be a 9. All right, so the 2 just stays in front. And then we're going to write in the first set of parentheses 4x squared plus 9. And the second one, we're going to do 4x squared minus 9. Then ask yourself, is everything completely factored? Is there anything I can still break down? And the answer is yes. I can break this down here. My a here would be 2x. My b here would be 3. So we get 2 times 4x squared plus 9. Cannot break that down. But this last part I can. So that last part will break down to 2x plus 3 times 2x minus 3. So I need to enter all this in. That's all part of my answer. Now let's bring in some grouping that we've done earlier with difference of squares. So here they're looking at this problem, and notice here they factor out a common factor of 9. Here they factor out a common factor of 2. My two pieces have a common factor of y squared minus 9. We bring that in front, but then I can use my difference of squares. So let's see how this works. So we're going to do our grouping here like before. X squared y minus 4x squared plus negative 25y plus 100. First two terms have a common factor of x squared, so let's pull that out. Leftovers would be y minus 4. And then the last two terms have a common factor of 25, but I want to pull out a negative 25. Y minus 4. My two pieces then have a y minus 4 in common, so I'll put that out in front. My leftovers are x squared minus 25, which is a difference of squares. So we're going to finish that off by breaking that down. That's going to be x plus 5 times x minus 5. All right, let's try the next one. So here we've got common factor of x squared, so let's pull that out. Y squared minus 9. And then here we got a common factor of 4, but I want to pull out the negative 4. So y squared minus 9. Looking at our two pieces, they have a y squared minus 9 in common. My leftovers are x squared minus 4. And notice that both the red and green are a difference of squares. So this breaks down into y minus plus 3, times y minus 3. And this breaks down to x plus 2 times x minus 2. Okay, let's try this next one. Oh, this is interesting. So I can factor out an x squared here. So that gives me x minus 5 for my leftovers. So I'm noticing I have an x here. I probably need to have an x here, so I want to try factoring out a 64. And if you do that division on your calculator, it does work out to be x minus 5. And now let's factor out the x minus 5. So my leftovers are x squared plus 64. It's not a minus sign, so I cannot break this down any further. This is as far as we can go. So just be careful. If that's a plus with a different square, that's not a difference of squares. Sum of squares, that cannot be factored. Now this one's kind of interesting. You have a u minus 2 y squared minus 49 y squared. So if a here is going to be equal to u minus 2, b here is going to be equal to 7y. So when I'm doing my factorization, I'm going to have this u minus 2 plus 7y, and then u minus 2 minus 7y. Then that will be my factorization. Now let's take a few minutes just to kind of overview all the factoring. So if you go to the next page, this is the factoring flowchart checklist, and you want to work from top to bottom. And so when you approach any factoring problem, you want to follow this list. So first thing you do before you do anything else is factor out the greatest common factor. And then you need to check, after you factor out the greatest common factor, looking at your leftovers, do you have 4 terms, 3 terms, or 2 terms? If you have 4 terms, then you're going to do your factor by grouping. If you have your 2 terms, we're going to factor using difference of squares. If you have 3 terms, then you have to split up into cases. If A is 1, then you're going to find m and m such that m times n equals c and m plus n equals b, and then rewrite it as x plus m times x plus n. If it's not equal to 1, then you're going to use the AC method. Or if you, for those that want to use the trial and error, you can use the trial and error here. We want to find p and q such that p times q is a times c, and p plus q equals b. You're going to rewrite ax squared plus bx plus c as ax squared plus px plus qx plus c, and then factor by grouping. And once you've done your factoring, you got to go down here at the bottom. Check, is everything completely factored? If not, run it back through this process. Whatever part's not completely factored, take it back through this process to get it completely factored.